So it's been after so long I didn't do the thing the past 3 days. But yeah, let's start again. Okay, so today we'll start with recursion. The basics of recursion. Okay, so what do you think recursion is? So basically we can state recursion as the basic thing is when a function calls itself directly or indirectly in its function definition, right? That is called recursion. Okay, so moving to the application part, where do we use this recursion thing? Okay, it will be used when the solution of a bigger problem depends on the solution of a smaller problem, where the smaller problem should be solved in the same way as the bigger problem. This is the basic thing. Whenever you find this type of questions, you apply recursion directly. Okay, so what does it say? The solution of bigger problem depends on the solution of smaller problem, where the smaller problem is solved in the same way as the bigger problem. Consider an example of factorial of number. How do we define the factorial? 5 factorial equals 5 times 4 factorial. 4 factorial equals 4 times 3 factorial. Now can you see the value of 5 factorial depends on the value of 4 factorial, which is evaluated in the same way as that of 5 factorial. So for these type of questions we can use recursion, right? Okay, so then how do you apply this? And so the basic is clear, right? What we are supposed to do, we will solve small problems and then return their outputs or the values they generate to the bigger problems, so as to facilitate our calculations, right? Like, so when you want to evaluate 5 factorial, you don't multiply till 1, 5 into 4 into 3 into 2 into 1. You just have this 4 factorial value evaluated and you just multiply. The recursion is also applied in dynamic programming, where you store the value of 4 factorial for future uses also. That's why it is an important thing. Okay, so what are the components of recursion? Like, suppose we have done with the basics of recursion, like where it is applied, what it actually is. Now let's move on to how do you write this in a code. Okay, so recursion basically has 3 components. The first is base condition, second is recursive relation, and third is processing. Okay, well, so base condition. For the base condition is the thing which tells the code where to stop actually. Consider the example of factorial only. You got 5 into 4 factorial, you got 4 into 3 factorial, you got 3 into 2 factorial, you got 2 into 1 factorial, you got 1 into 0 factorial, you got 0 into minus 1 factorial. This will move on till infinity. But where are we supposed to stop? We will stop at this condition. This will be our base condition. This states that whatever the manipulations you will perform till 0. Now, first of all, it is required, in this case, it is required for the correct evaluation purposes. But if you take -1, -4 it will generate an error, right? Again, what if there is no base condition given, that we forgot to write base condition in a code? What will happen then? Okay, the thing which happens is namely called segmentation fault. And the code will continue till the stack overflows. Now, what do you mean by stack overflowing? Look, when you call the functions, suppose I call the factorial function, this is main, I call it 4, you go to factorial of 4, then it calls factorial of 3, then it calls f of 2, this will move on till the stack overflows. And after it gets overflowed, we get an segmentation fault, we get the error in the code. That is the basic thing. So the base condition is very important for the evaluation purposes also, and to avoid stack overflow, to avoid segmentation faults, those things. Now the recursive relation is the relation between, we can say, the fn and the smaller which it is calling. It can be like this one, it can be like this one, and we will call this one, and this will again call this one, and like this the process goes. And the processing part is the evaluation part, like you update some values, you perform some arithmetic things. These things are included in processing part. Okay, fine. And again, there are there is a simple recursion type, like if the recursive call is called before processing part, it is called head recursion. If processing happens first, then recursive call is called, then it is called tail recursion. This is the basic thing. Okay, now let's start with let's discuss recursion tree, basically how the things are called. Okay, recursion tree, we will discuss stack directly. Okay, this is main function. Let us say we are concerned with the factorial function. Okay, so how do you write the factorial function? You write f, you write some int x, and then you write the base condition. Return statement is compulsory in the base condition, and then again what you return is, you return n into f of n minus 1. This is the recursive call. Okay, so you call phi, then you get to this function phi, you get to 4, you get to this calls 3, this calls 2, this calls 1, this calls 0. Now let us see how this function actually works. I wanted to get the factorial of 5, so I called the function factorial and gave the input as 5. It checks the condition, and I get to see that n is not equal to 0, so it returns n into n minus 1. So this will move to this, and again 4 will call 3, 3 will call 2, 2 will call 1, and 1 will call 0. So we get the return values from this. Okay, so f of 0 will return the value 1. This returns value 1 to this function, and then this function evaluates the value as 1 into 1. Then this returns the value 1 to 2, 2 evaluates the value as 2, 3 evaluates 6, this evaluates 24, and this will generate the factorial 120 value. So this is the basic of recursion, and again I guess there are many examples on this. Again you can generate any example, and I guess that's all for recursion basics.